Hello everybody and welcome to this video tutorial. Application cracking. This will be number 9. This will be this one. Alright. Okay. So the author requires us to make a keygen. I don't currently have like all the programming knowledge to write a keygen, and but what I did, it was like a pseudo-Keygen. Shit, this is too. Alright. So what I did is a pseudo-Keygen. So understanding the with the understanding of the algorithm, we will know then what will be the steps. What will be the steps in order to achieve a generation of any code for any username. Alright. Okay, so let's jump right onto it. Alright. Okay, so the first thing that we see is that whenever we go to the help menu, it actually gives us a hint, and it tells us that you need to see what the app does with your name. Alright, so we need to check what it does with our name. So let's do that. My user name. Try it. Let's put a breakpoint on. Go to all intermodal calls. Put a breakpoint on this get window text. Oops. What did I did? Okay. Put a breakpoint on this get window text A, which is the first instance that you see on it. And this will be the one loading up our username. We're going to start tracing from here, and I'm going to teach you what it's doing. Okay. So let's jump right onto it. So we step over this call, and what it's going to do is that's going to return. This call is going to return our username. As you can see, it returned our username right here. You're gonna say, how did it return already? Because it was prepared already for us. Okay. So as you can see in the comments, it's stored on 4030 E4, and as you can see above this call, that it pushed 19 onto the stack. It pushed this space in memory, 4030 E4, and then push these the data segment, and then it called the get window text A. Alright. So it's going to do the same thing with the password. We don't have a password, so it's not going to show nothing. It's not going to show nothing. There you go. Alright, so it's going to push ESI, which is a routine for the. It's calling a function, and now it's going to move my username into ESI. We're going to see that over here getting updated. Now essentially what's going to happen here, I'm going to resume. I don't want to take much time, sorry, 5 minutes ahead. What it's going to do here is going to take the first byte of ESI, and it's which is M, which in hexadecimal will be 6D. So 6D, it's M. So it's taking M, the first byte of ESI, and it's loading it into AH. So we're gonna see that over here. Let's jump over, and as you can see, 6Z has been stored in AH successfully. Then it's going to take the second value, or the second byte of ESI. In other words, it's going to be ESI plus 1, which is for the second value of the username, and it's going to store it next to AH, which is AL. It's 79 for for Y. 79, it stands for Y. Okay, so then it's going to shift left by 10 times into EAX in it itself. All right, shift at itself with leading zeros, and then it's going to put the other 4 letters, which is going to be U 75 and S. So what this does is that it takes its first 4 letters and it basically XORs them to this constant value over here. Essentially what it's doing, it's kind of a false thing, but essentially what it's doing is it's getting all these values, the first 4 letters, and XORing them against this value. Then it's pushing 1 into the stack. Then it's taking E, putting it into BH, R, putting it into BL. It's doing the same thing. It's shifting over left, and then it's taking the N, storing into BH, the A storing into BL, and then it's XORing this value, which is name. If you go over here, Erna. Well, it's actually, yeah. So what it's doing, it's taking the first 4, 1, 2, 3, 4, and then taking the other 4s where it's actually left off. All right. So it's taking 1, 2, 3, 4, and then 1, 2, 3, 4. Okay. So this algorithm only cares about the first 8 letters or the 8 characters of your username that you put on. From there, it takes that value, XOR it by this constant over here, and then what it's doing is that it's XORing both values, and then it's storing it, actually storing EBX into EAX. Alright. So it XORs both values and then stores the value on EAX. Alright. Then after that, moves the EAX into this place, this pointer in memory. As you can see, has been stored already. Then it pushes EDI onto the stack, and then it starts doing some stuff, which is actually placing the password. It's giving us a story again because we didn't, if you remember, we didn't put anything here. It actually compared our password with the one that it generated just right now. So the thing that is happening is that I'm going to restart here, and my username. Alright, so let's try one more time. Let's try it. So like I said, take the first two letters, Shift takes the other two letters, XOR, push CVX, take the other four, take the other, so it takes the first four letters here, and take the next four letters here. Alright? So basically, if you have a username like this, it will take the first four letters, and then the next four letters. So what you're left is with this result over here. Then what it's doing is taking the first four letters and XORing against this value. And then when it gets to this block, the second, which is how I call it, the second block, which is the other four letters, it's XORing against this value. Alright? And then it XORs again, and the result of this two calculations over here are XORed to themselves. Okay? So in order to do this, I don't have like the requirements to program my own keygen. So I did a Pseudo-Keygen. I found a solution online. It's basically bench, which is the first four letters, and then XOR against this, which is the console value. We're left with this, and then AMIN XORed against this. Oh sh. Okay, I'm so sorry for that. Okay, and the other one is XORed against this. The result of these two calculations will be XORed against themselves, and the result will be our password. So XOR, let me change this. XOR. It will be a password. Okay? So essentially, EDB. Then if we hit try it, it's gonna say successfully, well done, you did it. Alright? Okay. So that was basically everything. I don't want to extend myself up to like 20-30 minutes like I did in my previous video. I hope you guys understand something at least. I just tried to do it as most reasonable, as quick as possible I could do it. But hopefully you can understand what's going on in this, at least in this algorithm. It got me to think for a little while until I just like reverse engineered the algorithm itself. So thank you for watching and have a great day. Alright? Bye bye.